So the law of cosine, the law of sine 6.1. Uh, we've been doing a lot with right triangles, SOHCAHTOA and things, and Pythagorean theorems, and now we're getting into oblique triangles. And basically, what you need to know is uh, oblique triangles, they do not have a right or 90-degree angle. So these are triangles that you cannot use SOHCAHTOA, you cannot use Pythagorean theorem. You have to do different stuff. And when we talk about, if somebody says solve a triangle, um, you will find all sides and all the angles. All right, so from Algebra 2, you're probably familiar with the law of sines. And notice when you do these two equations, you can put the angles on top or the angles on the bottom and the sides on top, sides on bottom, doesn't matter, whichever way you want to go. And then also we do, maybe sometimes we work with the A's and the B's, and sometimes we'll work with the B's and the C's, but you only do one proportion, so one pair of angles or sides. Another thing to remember is people throw out the term opposite. And for instance, little a is the side and big A is the angle. They're opposite because angle A touches both of these sides. So angle A touches side B and angle A touches side C. The one side that it does not touch is side A over there. And so that's what we kind of mean by opposite. So let's go ahead and jump into one of these examples. And draw any triangle you want. I just typically draw something that kind of looks equilateral, and I usually just put A, B, C. And A will be 35 degrees, B is 50 degrees, and little a is 16, so little a would go here, and that's 16. So we have to find little b and little c. All right. So the first thing I would do is find angle C. Angle C will be 180 degrees minus, and I'm going to add the two angles that I know. So remember, a triangle has 180 degrees. Add the other two, that's 85. And so when you do that subtraction, you get 95 degrees. And I suggest anytime you have a triangle with two angles, whether you need to or not, find that third one. Now, the first one, let's go ahead and find little b. I put little b over the sine of 50 is equal to 16 over the sine of 35. Now, the only thing I have to do is multiply both sides by the sine of 50. And so on my calculator, we're going to go in here. We're going to make sure we're in degree mode, which I'm in degree mode. And if we look at the formula, I'm going to type in the 16 over the sine of 35. So 16 divided by sine of 35. I can go ahead and hit enter. And remember, we're multiplying now by the sine of 50. So we're going to multiply that by the sine of 50. And I'm getting about 21.37. And then we can do the same thing for finding C. Now, because I know both the angle for B and the side B, I can use these two. But if this is wrong, then I'm going to get this wrong here. So I always go back to the ones that were given to us. And I do have to use 95, which we found, but these two angles and sides were given to us. Now, some students choose to do what's called cross multiplication, and you can take C times the sine of 35 is equal to 16 times the sine of 95. So just another way to do this. So we're going to type this into our calculator. 16 times the sine of 95. And then now I have to get c by itself, so I'm going to divide by the sine of 35. And we're getting 27.79. And if you put that in there, 27.79 and 21.37, just to double check, like these two, the smallest angle, smallest side, these two, biggest angle, biggest side are opposite, so that's kind of what you want to end up with at the end. All right, there's a DIY. Draw your triangle, solve for the missing stuff. Pause the video now. Okay, so we have, this is the way I drew it, A, B, C, and then here are your answers. B should be 45.25. The missing angle would be 105, and 61.82 for the side C. All right, example 3, if I draw again, just like the ACT, I tell students when I draw the triangle, it's not to scale. I don't worry about anything. I'm just going to label it how I want to. So I go ABC again. If A is 43, B is 98, and C is 22. We call this one angle side angle because I know two angles and the side between them. Some students forget, but you need to find angle C first. So you're going to do 180 minus 98 plus 43. So doing that, I believe will give us 39 degrees. And then I can go ahead and find little a. So I can do sine of 43. And little a over sine of 43 would be the same as 22 over the sine of 39. And so we just go to our calculators, 22 over the sine of 39. 22 divided by the sine of 39 is 34.96. And then we have to divide that by the sine of 43. So I'm getting 51.26. And then I can find, what do we need? Little b over the sine of 98 is equal to, let's do 22 over the sine of 39 again. So now, like on your calculator, you can hit second, enter. If you hit that a couple times, it'll recall your 22 over the sine of 39. So we hit enter again. And this time, we're multiplying by the sine of 98. And I'm getting 34.61. I'm going to go back now. I feel like I mishit the buttons for the blue one, so let's go back and check the blue one. So 22 divided by the sine of 39, so 22 divided by the sine of 39, it gives me that. And now I want to get rid of sine of 43, so I have to multiply both sides by the sine of 43. I feel like looks like, yeah, I divided, so I have to multiply by the sine of 43. And I get 23. So I don't get that. I get 23.84. That's better. All right, so the next thing is the ambiguous case. And if you Google law of signs ambiguous case, there are a bunch of videos that can come up, and maybe that um, might help explain stuff too. But basically, we're going to break this into two situations. What's happening is we have what's called the side-side angle, or the ASS, and these were not used in geometry for congruent triangles. They are not congruent rules. And the reason is we can have two different triangles. So I'm going to try to explain this to you. For instance, if I gave you this stick here and this one, and I told you maybe this angle down here was something like, 40 degrees or something. So you'd have to lock that in. And so this red one has to stay at that angle. The thing about this blue one is we can actually rotate it. So I'm going to kind of rotate it in and move it. And what's going to happen is it can end up somewhere like this. And so you could have this triangle that kind of looks like this bigger one, or you could have this little tiny skinny triangle. And that's what is truly the ambiguous case. And so what kind of, visually what's happening is the tip of that line comes down here, and then it starts to go back up, and it hits there. So hopefully you can visualize that blue side swinging in. So there are two different cases. So what these rules are telling you for this is, one, acute. Remember, acute triangles less than 90 degrees. Well, if you have the angle side, and I'm going to refer to this as the partner side, and this as the other side. So if your angle is acute, angle A right here is acute, and your height is bigger than the partner, so remember H stands for height, and this is the partner side over here. So when the partner is small and the height is big, that creates this gap right here. So that's why there are no triangles. Now, if your height and what you thought are the other side are equal, so the partner side and the height here are equal, then there's one triangle. If this angle is acute, and this is big, and this is small, you have one triangle. And last, if you have an acute angle and it goes height, partner, other, then you have two triangles. And that is what we call the ambiguous case, and that's why you can't use it as a congruence rule. So it can happen that there are two triangles. Now the last couple rules right here, remember we're talking about obtuse, more than 90. And if it's an obtuse angle, you have to check is the partner smaller than the other? If the partner is smaller than the other, there are no triangles. And if the partner is bigger, then there's one. So we're going to run through a couple of these examples and see what's happening. Now, this is the angle and this is the partner side. So I want people to get in the habit of, we put the 42 there and the 22 here, and we'll put the 12 there so that it's the same thing every time. You got stuff in the same location. Well, this is a situation. This is acute, and this is big, and this is small. When that happens, you have one triangle, Because if you tried to swing this back, if this is 12 and this is 22, it would be down here, and it can't touch. It couldn't come back here and touch it. 22 is too long, so there's just the one triangle. So I just draw it. I don't draw them to scale, so I'm going to put my 85 there. The partner side is 15, and this is 25. So in this case, it is acute. The partner is smaller, so now I'm going to drop a height down. Now when you look at just this right triangle, I can do SOHCAHTOA. So sine of 85 is equal to the opposite height over 25. So if I go to the calculator, all I have to do is multiply by 25. So 25 times the sine of 85, and I get 24.9. Well, that means that the height is going to be somewhere up here, and 15 would be like right there. And there, right? Doesn't touch the ground. It's too tall. The height is too tall. So 24.9 is bigger than 15, which is the height is bigger than the partner. 0 triangles. All right, you do this one as a DIY. So pause the video now. All right, so here's your triangle, again, not to scale. So I like to put the angle here, partner there, other side there. And when you calculate for the height, you should have gotten something like 10.86. So when you look at it, the height is smaller than the partner, which is smaller than the other side. That means, whoops, that means 2 triangles exist. Now, how can we go about finding them? Let's take a look. All right, so now I know there are supposed to be 2 triangles. So with the information, I can go ahead and solve triangle number 1. I can find angle B by doing the sine of B over 31 is equal to sine of 20.5 over 12. So what does angle B equal? So I do the sine of 20.5 . Make sure you close it before you divide by the 12. So I have that. Now we're going to multiply by 31. I get that, so that's a decimal. But remember, I don't have B by itself yet. I have the sine of B. So to get rid of it, I'm going to go second, negative, second sine, second, negative button. We'll throw my last answer in there. And I'm getting something that's about 64.78. Now I can do 180 minus 20.5 plus 64.78. And the missing angle up here would be 94.72. And so now I can find little c over the sine of 94.72 is equal to, I can do 12 over 20.5 again, sine of 20.5. So I'll run back to the calculator, clear that out so we can see it. We're doing 12 . 12 divided by the sine of 20.5. Now I have to multiply, we're multiplying now by the bottom here. Multiply by the sine of 94.72. I'm getting about 34.15. All right, so now if I'm going to solve triangle 2, remember I kind of showed you that diagram where we're going to let this side right here kind of swing in, and it's going to kind of end up over here. So if I do that, I'm going to bring this over, and we're going to call that 12 still. And what I've created is an isosceles triangle. I have two sides that are 12. And so if it's an isosceles, then I also know this is 64.78 base angles in the isosceles right here, this isosceles triangle. Those are going to be equal base angles. And so the first one right here, this angle, I can find by doing 180 minus 64.78. Those are called the linear pair. And so 180 minus 64.78 is 115.22. So that's 115.22. And now I can add to 20.5 to find the missing angle up here. So if I add to that 20.5, my two angles sum up to that, and I can do 180 minus my answer there, and I get 44.28. So this one is 180 minus 20.5 plus the 60 plus the 115.22, and I got 44.28. So those first two angles, it's really like back to geometry days with isosceles and linear pair. Now to find little c right there for the second triangle, I do c over sine of 44.28 will be equal to, let's do the 12 on top of the sine of 20.5. So again, let's clear this out so you can see. We're doing 12 divided by the sine of 20.5. Now we have to multiply. Now you're going to multiply by this denominator, sine. So multiply by the sine of 44.28. And I'm getting 23.92. So there you go. That's, once you found maybe this regular triangle here, swing that side in, use isosceles, and do that. All right, the last one down here is a DIY. So let's have you pause the video, find how many triangles, then solve it if needed. Pause the video now. All right, so if you draw your triangle, put the angle, partner side over here, other here, and you find that you get a height of about 8.99, so basically 9. So that means height is smaller than the partner, which is smaller than the other. So we have two triangles. Now, when you do triangle number 1, you can go ahead and find that B is 0.58. And if you use that as a reference angle, the other one is 131.42 from here to here. And so those two right there, you could think of as what is the angle and what is the reference angle. Now, if the second angle is 48.58, add the 40, and the third angle is this. Set up your law of sines. This one you'd cross multiply, you get 18.66. So again, law of sines would produce this. So this time, I'm not showing you with isosceles triangles. We're just using angles and reference angles. Now add the two angles together, and you're going to get a 8.58. That would be the skinny triangle up in here. And then you do law of sines again, and you get 2.79. So hopefully that made sense. All right, area of oblique triangles. What we're talking about is when you have this triangle, you can drop a height down, and hopefully you can calculate what the height is, and it's 1/2 base times height. On a triangle like this, the height is outside over here. So again, if you knew this angle, you could do a reference or a linear pair, and it's a little more work. So what we're talking about is this is 1/2 base times height. Right there, base times height. But instead, we're going to ask you to memorize, or at least I would tell my students, memorize this formula. And this is going to work when we have side, angle, side. So for instance, when I look at this triangle, I have a side, an angle, and a side. I can immediately go to the oblique triangle formula by doing area equals 1/2 times 52 times 90 times the sine of that included angle of 102. I don't have to worry about trying to drop an altitude down or anything. So let's just go right to our calculator. And 0.5 times 52 times 90 times the sine of 102. And I get 2288.87. meters squared. So I'm going to have you try the next one on your own. Make it a DIY. Draw your triangle. You're going to have side, angle, side. So go ahead and use the formula and see if you can get it. Pause the video now. Now you'll notice when this person did the formula, they did the side, sine of the angle divided by 2. That's dividing by 2 is the same as multiplying by 1/2, so that's fine to do it that way. And you should get 692.82 units squared.